Have you ever wondered if your lucky socks actually help your team win? I mean, really, we're surrounded by headlines and claims that one thing causes another. Well, in this explainer, we're going to give you the mental toolkit to tell the difference between a real cause and something that just looks like one.
We've all been there, right? You put on the lucky socks, your team pulls off a win, and you think, I did that. It feels like you've got a superpower. But come on, was it really the socks, or is there something else going on here?
Okay, here's the deal. Our brains are pattern-finding machines. It's a survival skill, really, that helps us make sense of the world. But that incredible ability can sometimes backfire, making us seek connections that, well, they just aren't there. They're nothing more than a coincidence.
So our first stop on this journey is to really wrap our heads around this idea of correlation. This is ground zero for so many of the myths and misconceptions we're about to bust wide open. Think about it like this. On days when ice cream sales shoot up, the number of drownings also goes up. Now, those two things are definitely connected. They are correlated. But does eating ice cream make you forget how to swim? Probably not. And that is the exact puzzle we're here to solve.
So these relationships, these patterns, they generally move in two main directions. You've got your positive correlation, where two things move together. Like the more you study, the higher your test scores get. Then you have negative correlation, where they go in opposite directions. For example, the more you exercise, the less you might weigh.
And here's a perfect real-world example of that negative correlation. When it gets colder outside, what happens? Your heating bill goes up. It's a clear, undeniable link between those two things. One goes down, the other goes up.
And then sometimes there's just nothing. No connection at all. You know, there's a surprisingly strong correlation between the number of pirates in the Caribbean and rising global temperatures. As pirates disappeared, the planet got warmer. Is one causing the other? No way. That's what we call a zero correlation.
So we see patterns. We get it. But now, let's look at how our own minds can play tricks on us, basically creating these ghost patterns out of thin air.
And this brings us right back to those lucky socks. It's the perfect example of an illusory correlation. Our brain just loves to remember that one time we wore the socks and the team won, but it conveniently forgets the 5 other times they lost. We literally invent a pattern that isn't really there. Now here's another tricky one our brains fall for: regression toward the mean. You know, when an athlete has a mind-blowing, record-breaking game, they aren't jinxed if they have a totally normal game the next day. They're just returning to their average. It's totally expected.
Yeah, it's not some kind of curse. It's just math. An extreme event, by its very nature, is rare. So over time, things have a natural tendency to drift back to the middle, back to the average. It's this powerful, invisible pull.
Okay, all of this, every single one of these examples, brings us to the most important rule in all of statistics. This is the main takeaway. Say it with me. Correlation does not equal causation. Just because two things happen together does not mean one caused the other. You got to remember that. So, if just seeing a pattern isn't enough, how do we find the real culprit? How do we go from just having a hunch to having cold, hard proof? The answer? Well, it lies in the scientific method. We have to stop just watching things happen and actually become detectives. We have to design careful experiments that can isolate the real truth. You know, a really good experiment is kind of like a great story. It starts with a big question, it introduces one single change, the plot twist, and then it builds to a clear conclusion. This is really the only way to prove that one thing truly causes another. And the secret ingredient, the real magic, is comparison. You have one group, the experimental group, that gets the thing you're testing, and then you have the control group, which gets nothing or maybe a fake. By comparing what happens to both groups, you can finally see the true effect of what you were testing. Now, to make sure that comparison is totally fair, researchers use what's called random assignment. It's literally like flipping a coin for every person in the study to decide which group they go into. This makes sure the only real difference between the two groups is that one single thing we're trying to test. So let's talk about these variables. The independent variable, that's the one thing the scientist changes on purpose. It's the potential cause. You can think of it as the new medicine in a trial or the new teaching method in a school. And the dependent variable? That's what we measure. It's the effect. Did the patient's health change? Did the test scores go up? That outcome depends on the change we made with the independent variable. See how that works? But look, the real world is messy, and it's filled with these hidden factors that can completely mess up an experiment. We call these confounding variables. For example, What if people taking a new miracle vitamin also happen to be getting more sleep? How would we know if it was the vitamin or the sleep that was actually making a difference? So how do scientists keep themselves honest? I mean, how do they make sure their own hopes and expectations don't accidentally color the results? Let's take a look at the really clever ways they outsmart their own human biases. To fight something called the placebo effect, scientists use blinding. In a single blind study, the people in it don't know if they're getting the real pill or a fake sugar pill. But the absolute gold standard is the double-blind study. That's where nobody, not the participants, not even the researchers handing out the pills, knows who's getting what. It's the best way to make sure the results are pure. Okay, let's bring this all home. What does this actually mean for you in your life? Why is it so important to know the difference between just a pattern and a proven cause? Because the next time you see a headline that screams, "Drinking coffee helps you live longer," you'll know exactly what to ask. Was this just a correlation they noticed, or was it from a properly controlled double-blind experiment? Learning to think like a scientist is a superpower. It lets you cut through all the noise and make smarter decisions. And in a world that's just flooded with information, what could possibly be more valuable than knowing what's real?